I like RO say something.
Hello, welcome to section 6 for Rational Exponent. This is our 11th week lesson. In this lesson, we will see how to simplify rational exponent. Okay, we will see how to simplify expression involving rational exponent. Then we will see how to convert uh, exponential expression to radical form. And then we will see how apply rational exponent in our real life situations, and then we will see how to combine radicands with radicand. If you remember, in section 3 we saw how to find the sum and difference of radicand with the same radicand and without the same radicand. But in this lesson we will see how to combine radicand involving like radicand. And then finally, we will see how to simplify numbers with rational exponent. Okay, I like to begin the lesson with a key concept of rational exponent. If the nth root of a is a real number, m is an integer, and m over n is in Law's terms, this is very important. Therefore, a the power of 1 over n is the same as the nth root of a. Okay, the nth root of a, and a the power of m over n is the same as the nth root of a the power of m, or the nth root of a the whole power to m. This is a very important concept. Here, as you can see, 1 over n, which is rational, okay, with the denominator n. This n is the index for the radical a. Okay, n is the index. The denominator n is the index for the radical. In this case also, where the numerator of the rational is different from 1, which is m in this case, okay, the denominator is n, and again, n is the index for the radical expression. This is a very important concept that you have to keep in your mind. So, a the power of 1 over n is equivalent to or equal to the nth root of, okay, here the denominator n become the index for the radicand, okay, a. This is one concept that you have to know. And if the numerator of the fraction, if it is different from 1, let's say m, so a the power of m over n is the same as the nth root of a the power of m, okay, sorry, this is m. Or I can write this in another form, okay, which is the nth root of a the power of the whole power of m, okay, the whole power of m. So this is our basic concept for this lesson, okay, this is our basic concept. Keep this in your mind. Okay, now if you know this thing, now we can directly proceed to the problems. Okay, problem 1. In problem 1, we are going to simplify rational exponent. So problem 1 says, what is the simplified form of the expression 216 the power of 1 over 3? 216 the power of 1 over 3. Okay, so this problem 1. Okay, I'm going to simplify 216 the power of 1 over 3. So in order to simplify this rational exponent, okay, what I need to do that I will convert this rational exponent to radicand form. In order to do that, first I have to identify the denominator, in this case, which is 3. So as you know that from our key concept, the denominator, okay, is the index for the radicand. Therefore, here the denominator is 3, therefore it will be the index. It will be the cube root of 216. 216. Okay. Then how can I simplify this one? To simplify this one, what I need to do that, I'll try to express the radicand, which is 216, at the power of 3. Why I'm doing that? Because the index is 3. So 216, when I try to write it as a power of 3, it's going to be 6 times 6 times 6, which is equivalent to, say, 6 to the power of 3. 6 to the power of 3. Therefore, the cube root of 216 is the same as the cube root of 6 to the power of 3. The cube root of 6 to the power of 3. And from our section 1 lesson, if the index and if the exponent within the radicand, if it is the same, then we can cancel out, which is equivalent to 6. Okay, so 216, the power of 1 over 3 is equal to 6. Okay. By the way, I can do this question in another way. Okay, how I'm going to do it in another way? 216, the power of 1 over 3. Okay, the power of 1 over 3 is equal to, okay, since I know that 216 is equal to 6 to the power of 3, therefore this can be written as 6 to the power of 3, the whole power to 1 over 3. Then I will apply my previous knowledge of exponent. I will apply the rule of the exponent. Here the power of power can be written as a product of the exponent. Therefore, 6 to the power of 3, the power of 1 over 3 is the same as 6 to the power of 3 times 1 over 3. Then multiply these two numbers, you'll get 1. 3 by 3 will be cancelled out. Therefore, this is equal to 6. So you can simplify rational exponent without converting to radical expressions. Okay, so we see two ways of simplifying rational expression. Okay. Okay, the next problem you are going to practice converting exponential radical exponent to radical form. In this problem, you are asked to change x to the power of 3 over 7 to radical form. Okay, so what is x to the power of 3 over 7 in radical form? So in order to convert this rational expression to radical form, I will apply the key concept that I discussed. Okay, in problem 2, you are asked to convert the rational expression, the rational exponent, x to the power of 3 over 7. Okay, x to the power of 3 over 7 in radical form. So x to the power of 3 over 7 in radical form. Okay, so to do this one, I'm going to apply the key concept. In our key concept, if the denominator of the which is in this case 7, will be the index for the radical. Therefore, it will be the 7th root of x to the power of 3. Or I will convert this into another form, which is the 7th root of x, the 7th root of x, the whole power to 3. So these two expressions are equivalent. They are equivalent. Okay, another thing that I would like to stress in this problem, every time when we have rational exponent, the first thing that we need to do is that we need to check whether the rational is written in simplified form or not. In this case, 3/7. Is it written in a simplified form? Yes, we cannot simplify it to another expression. So we just directly change the rational exponent to radical expression without simplifying the rational exponent. So mind you that you need to check whether the rational exponent is written in simplified form or not. Okay, this is another thing that you need to keep in your mind. Okay, the next problem is why the power of negative 3.5 in radical form. Okay, this is a little bit different from part A. In part A, the exponent is rational, but in part B, the exponent is decimal. It's not rational. So let's see how we are going to convert uh, the decimal exponent to radical form. So why the power of negative 3.5? Negative 3.5. Okay, in order to convert this uh, decimal exponent to radical form, our first step should be we need to change the decimal to rational expression. So let's convert negative 3.5 to rational expression. So negative 3.5 is the same as negative 35 over 10, since we have only one digit after the point, so the denominator will be 10. Then we need to check whether this is written in simplified form or not. So as you can see, it is not simplified form, so I have to simplify it. So to simplify it, I need to divide the numerator and denominator by 5. So 35 by 5, it will be 7. Okay, it will be negative 7 because it is a negative number, over 10 by 5, it will be 2. Okay, then I'm done with the first step, changing the decimal to rational exponent. Then this will be equal to y the power of negative 7 over 2. Negative 7 over 2. Then what do you think will be the next step? The next step is, since the exponent is negative, I have to make it positive. Okay, I have to make it positive. If you remember from your previous knowledge of exponent, okay, one of the rules say that if we have a power with a negative exponent, we can change it to positive exponent by taking it reciprocal. So for example, a the power of a negative x is equal to 1 over a raised to x, or a the power of x. Therefore, when we change this negative rational to the positive, I have to take the reciprocal of the power, which is 1 over y the power of 7 over 2. Okay, now after this it will be simple, because this is the same as part A. Then I can change these to radical expression. How can I change this to radical expression? By applying the key concept. Now here our index is 2. Our index is 2. Usually if the our denominator is 2. So if the denominator is 2, we don't have to write as index of 2. So simply I can say 1 over the square root of y to the power of 7. If you write 2, there is no problem. If you write 2, there is no problem. But usually, or in most cases, we don't have to write the index 2. So I don't need this time. So I need to erase this one. Okay, I will erase it. Oh, sorry, let me rewrite it again. Let me rewrite it again. So I'll get 1 over y, the power of 7 over 2 is the same as 1 over, since the index is 2, simply I'll write the square root of y the power of 7, y the power of 7. And then what? And then I have to simplify the radical. The radical. So how can I change this into radical expression in more simplified form? Since the index is 2, I need to rewrite, okay, I need to rewrite y the power of 7 as the power of 2. So let's rewrite this one. What is y the power of 7? Y the power of 7 is the same as, okay, the same as y the power of 6 times 7. Oh, sorry, times, okay, times, which is times y. And I know that y the power of 6 is the same as y the power of 3, the power of 2. Why I'm doing this? Because my index is 2 times y. This is section 1. In section 6.1, we saw how to find the end root of powers. So this is 1 over the square root of y the power of 7 is the same as y the power of 3, okay, the power of 2, the power of 2, the power of 2 times y, times y. Here we have, let me extend this one, okay, y is in the square root. Therefore, because the index is 2, okay, and I have exponent 2, so I can take out y the power of 3. Therefore, I will get 1 over y the power of 3, okay, y the power of 3. And since the exponent for y is 1, which is totally different from 2, so I cannot take out y from the square root. So I will keep this one under the square root, okay, under the square root. Sorry, let me erase this one. Okay, let me erase this. This time I have to be careful. Okay, so this will be the square root of y, the square root of y. So the square root of y. Now I can put it as it is, but in most cases, whenever we have uh, square roots in the denominator, we need to remove it. So in order to remove the square root of y, what I need to do, I will rationalize the denominator. So to rationalize the denominator, or to remove the square root of y, I will multiply the numerator, okay, and the denominator by the square root of y. Okay, then what I will get? This will be the same as 1 times root 5, this is the square root of y, okay, the square root of y, is equal to the square root of y, the square root of y, over the square root of y times the square root of y, it will be y, therefore I will get y the power of 3, y the power of 3 times y, and y the power of 3 times y will be y the power of 4. So my final answer will be the square root of y over y the power of 4, y the power of 4. So this is problem 2, part B. Let me summarize what I did here. The question is, what is the radical form of y the power of negative 3.5, or rewrite y the power of negative 3.5 to radical form. So the first thing that I did, I changed negative 3.5 to rational expression, which is equivalent to -3, -7 over 2. Then after that, I change the negative radical, the negative rational to the positive one by taking the reciprocal. It will be 1 over y the power of 7 over 2. And then I change it, the rational exponent to radical form. And after that, I simplified the expression. Then finally, I get this one. Okay, problem 2, part 3, part C. What is the square root of a the power of 5 in exponential form? This time, the radical expression is given. We need to change this to exponential form. Okay, so uh, the square root of, okay, the square root of a, the square root of a, the square root of a, the power of 5. I need to change this to exponential form. So to do this one, the first thing that I need to do is I need to identify what is the index. In this case, nothing is written. So if nothing is written, which means that our index is 2. And from our key concept, we know that the index is what? Is the denominator. Okay, it is the denominator for the exponent. Therefore, this will be the same as a the power of 5, okay, 5 over 2. So the radical expression is changed to rational exponent. Okay, the rational exponent. So we can convert the radical form to rational form. And the last problem is, what is the fifth root of b the power of 3, the whole power of 3? The fifth root of, okay, b the whole power to 3. And again, we will apply our key concept. So here the index is 5. Since the index is 5, I can use it as the denominator of the exponent. Therefore, this is equal to b, okay, b, sorry, let me write again. So it will be b the power of 3 over 5. Okay, so here again we are practice how to convert uh, radical expression to rational exponent. So we finish problem 2, part D.